I'll continue on the thread of the evening, which is continuing on this idea that water is such a part of us. We are water, and yet it's this mystery. So I'll begin with this, which you may have seen when you came in: respect, restore, replace, which is a trio that I developed to describe the hierarchy that we should have when we approach preserving and conserving natural places and natural ecosystems. So if you know everybody knows reduce, reuse, recycle. So, but sometimes we forget that there's an actual order to that sequence. And first priority is to reduce, then reuse, and then recycle. And the same thing applies here. The most important priority is to respect. And at last month's DASER, Helen Fisher ended her presentation by saying, let's not just think about the golden rule, let's think about the platinum rule, whereas do unto others as they would have you do unto them. And as we approach environments and organisms that are different from ourselves, this is something that we can think about. So our lovely blue planet, covered mostly by water. Oceans contain 97% of Earth's water. Over 1/3 of the US gross national product is from coastal areas. 1 in 6 jobs are ocean related. 90% of global trade is through ocean-bound shipping. Most of the world's big cities are on coasts. And you may have seen these very striking images from space of how the light that we produce, shows up in space, which is a rough approximation for where people are producing light pollution. And all of this is pollution because we're not trying to light up space. We're trying to light up the Earth. But you can notice that we basically are forming an outline around the continents. And in fact, in coastal regions, there's 3 times the population density than the global average. So we're very tied up with water and the oceans. So, but then there remains this mystery. So think about the ways that we talk about the ocean. Talk about a deep ocean of chaos and darkness, an ocean of secrets, an ocean desert of waters. And even from our US Geological Survey, over 99% of all water, and especially oceans and seas, is not available for our uses. Yes, fresh water is very important, but what about all these uses that we have for the oceans and how tied we are to the oceans? So continuing on our sensory exploration of the evening, I would like us to think about reorienting to sound. And this is something that is a bit of a challenge because humans are very visually oriented. Our brain is structured visually, our language is structured visually, our cultures are structured visually. We're very oriented to the visual. And just think about some of the phrases that we just take for granted that have shown up this evening. You know, seeing, observation, take a look at. So let's start to consider this world of sound. In the ocean, as Connie mentioned, color is absorbed very quickly, but all light is absorbed very quickly in water. However, sound travels 4 times faster in water than in air. This is huge. This is the medium of choice underwater, is sound. And in fact, is extremely important to marine organisms. So take this little critter in the middle, the snapping shrimp. And you heard the sound that you were hearing as you came in was actually recordings that I took from a coral reef, and a lot of that was snapping shrimp. So these are little critters about the size of your pinky. And they are responsible for the loudest sounds in shallow waters. These little guys. So they have this big claw, which they snap shut. You get all of them together. It's so loud that it interferes with Navy sonar and submarines. And they are, the Navy is very interested in how they mask submarines. So they've been these little guys. And we don't even really know how they're using the sounds, but we know that they're important in self-defense, communication, possibly in coordination of behavior. Something you may be more familiar with, like humpback whale songs. And unfortunately, in many cases, we start to learn about things as they start to get destroyed. So a lot more is coming to light about the communication of marine mammals as shipping noise is obscuring their ability to do that and find each other to mate. And in addition to communication, we know that dolphins actually see through sound, through echolocation. So sound is extremely, everything about the life of marine organisms is necessarily oriented towards sound. So in order to understand the oceans, we need to record sounds. Now we have a global need for baseline data. In order to evaluate the urgent pressures that we're hearing about in the news, toxins, plastics, climate change, ocean acidification, overfishing, we need to be able to evaluate those changes based on something. And as we hear, the time is right now. Also, it's going to require a coordinated effort. So if it's global, we have to have coordination. So there needs to be a way to make things standardized across regions, and it has to be a continuous data stream, and there has to be some degree of openness and sharing of data among researchers. Also, it needs to be passive. We don't want to be introducing, we want to minimize what we're introducing into the environment, and as much as possible be the fly on the wall listening in to what's going on so that we get clean, clear data and we're not disrupting the ecosystem while we're getting it. So we need to work this so that we have this data over not just short-term cycles, but also long-term cycles. Because if we want to get a fix on really important systems and things that are cycles that are happening in the ocean environment, like seasonal migrations, life cycles, we have to take that into account in how we are collecting data. And we also need to keep in mind that this needs to be reproducible across multiple different types of ecosystems. Obviously, you need to tailor the approach to a particular location. Every location is different, but there has to be some degree of comparability. And again, we want to minimize disruption to the environment while we are doing that. So a tool which I think is incredibly useful and important and timely is passive acoustic monitoring. This is essentially listening. And it has a lot of advantages. It's similar to visual surveys. You might picture people going along underwater on a transect counting fish. But it actually can be more comprehensive. It's minimally invasive. You're just listening. You're not introducing anything. It is low cost. That's a good one. And you can get continuous long-term sampling, including in situations that you can't do with visual surveys. For instance, you can record at night. You can record, as I found out, right at the very beginning of my study, during storms and hurricanes. You can hopefully continue recording even if there is a political upheaval going on and you can't get to the equipment. It's hopefully staying out there still recording for you. So this has a lot of advantages and has a lot of potential for giving us the information that we need about the oceans. So encoded in sonic information, there are a lot of pieces of information that we can potentially tease out. Identifying particular species, not just their presence, but also activity. So animal behavior, biodiversity, ecosystem health, anthropogenic influences, weather pattern influences, and trends in ecosystems over time and space. And I was interested to hear what Hallie was mentioning about putting the timelines together and noticing, taking two different timelines, focusing on two different subjects and putting them together, because I think that's the kind of thing that we need to be doing. We need to be looking at what trends are happening, with this one type of data, with this other type of data. What's happening with the weather at the same time as the activity of this organism. That's the kind of thing I think that we need to be doing. So a relatively new apparatus that we can use and that I'm using is the Ecological Acoustic Recorder, or EAR, aptly named. So this is an autonomous system for recording underwater sounds. It's stationary. You put it there, and then you leave, and you leave it there basically spying on the ocean for you. So this is a device that was developed jointly by NOAA, the Hawaii Institute of Marine Biology, and Oceanwide Science Institute. So it rests on the ocean floor. You program it to record at regular intervals, sampling the sounds that are there. It runs on batteries. And it can be left for a really long time. We're talking months to a year that you can leave it sitting there recording. That's a lot of data. When you are, for instance, as I'm doing, you can record 30 seconds every 15 minutes. That's a lot of data, day and night. Weekdays, weekends. So in developing this global baselines that we really need, now there's technology available. And decoding the sounds and the process of decoding the sounds and piecing apart how do we get these pieces of information that we need, that's underway in a number of places, including at Oceanwide Science Institute, based out in Hawaii, and the Biomusic Research Group at the University of North Carolina, Greensboro. And the other groups working on this as well. And we really need people to be working on this because we need a lot more information here. And we need a lot more people working on this. So a place that I think is very interesting and is not talked about that much is the MesoAmerican Reef. So who's heard of the MesoAmerican Reef? Who's heard of the Great Barrier Reef? Okay, Great Barrier Reef, all right. It's the largest coral reef system in the world. MesoAmerican Reef, second largest, and it's right here next to us. It's our reef, and you guys don't even know about it. Who's been to Cancun? You've been to the MesoAmerican Reef. So, see if I can figure out this laser pointer. So for your reference, so here we are, the Yucatan Peninsula. Here's Cancun, all right? Here's Mexico. And the MesoAmerican Reef stretches all along here, Mexico, Belize, down through Honduras. So what's going on down there? Well, we didn't know, so let's find out, right? Oh, this is just I was looking at Wikipedia just to see what they had to say. This is the entry for the MesoAmerican Barrier Reef, a piece of dead coral, versus the Great Barrier Reef with a nice map and pictures of turtles and coral. Just saying. So, okay, how do we start to establish a baseline? How do we start to get information about the MesoAmerican Reef? Well, I started working on this when I got a fellowship to go work with the National Parks Office in the Mexican National Parks Office in Cancun. And I quickly realized that I needed to back up and start doing some work on what is the native wildlife there, because Cancun is a really wonderful opportunity for research. It's got amazing natural resources. It's right on the Mesoamerican Reef. But it's also, we put it there 40 years ago. And this is a planned tourism destination. So it's a wonderful place to be looking at the dynamics of humans as part of this ecosystem and figuring out, well, what's working, what is sustainable, and what needs to change so that it is sustainable, and can it be changed? So I worked on that, then met up with Jason DeCare-Taylor, underwater sculpture artist, and we got to talking, and I was thinking about his sculptures and the evolution of how life grows on his sculptures, and we were talking about how to document that scientifically. I said, well, why don't we put a hydrophone in there? Why don't we put an underwater microphone and listen to how an artificial reef develops? And he loved the idea. We were really into it. Took us 2 years to find funding, but okay, we get there. So meanwhile, I was working on getting the first ears out into the water. Finally in 2010, got the first ear out there in collaboration with the National Parks Office, Oceanwide Science, Uni-Caribbean, Michelle's Earth Foundation, and then working on expanding that network. So in collaboration with and with support from the Biomusic Research Group and Patricia Gray at the University of North Carolina, Greensboro, and with the Oceanic Society now in Belize, there are now 4 ears monitoring the Mesoamerican Reef. So this is a good start. This is what the ear looks like. Nothing much. This is when it was the first one was first deployed. This is after a while, stuff growing on it. Still works just fine, even with lots of things growing on it. This is the sculpture, The Listener. So this sculpture was designed by Jason DeCare-Taylor. It's got the ear in this part in the back. The ear is housed here in the back. And all of these ears were actually molded from kids at a local school in Cancun. So they got actually invested in the process as well. And that's me. So I wonder if we could play a few sounds, Chris? So you may have heard a little bit of background crackling that you might have thought was static when you walked in. But I'd like everybody to close your eyes and imagine yourself in the coral reef and just listen to the tapestry of sound. Heard people describe this like, oh, it sounds a little bit like you're in a forest. There's all kinds of critters in there doing all sorts of things. And the ears just listening to it all. All right, that's probably good. I could listen to it all day, but I don't need you guys to. Actually, when I got one of the first recordings back and I played it for a friend of mine, it was amazing because as I started the recording, I just saw this look, this sudden look of amazement and awe come over my friend, and so I said, like, well, what's going on? And it turns out that, and I didn't know this, my friend years ago used to free dive, and it immediately took her back. And I think the sounds they're very palpable. I think they have they sort of reach into you. And there's a difference between, as was mentioned, there's a difference between free diving and scuba diving. So scuba diving is this wonderful thing. I love it, and it's amazing that Jacques Cousteau opened up the oceans to us. And now we're on to the next step, because with scuba diving, it actually obscures your ability to hear, because it makes the bubbles all the time as you are exploring the water. So as we're talking about our visual perspectives, so what do we do with the sounds? Okay, we have the sounds. They sound great. Now what? We actually turn them into visual graphs. And this is a way for humans to wrap our brains around sonic information that isn't what we're intuitively used to dealing with. To translate into, this is a spectrogram, and what you're seeing is frequency on the y-axis. The color itself is the intensity of the sound, like the loudness of it, and time on the x-axis. So this is a conversion of the sound information into something visual. And it helps us to, figure out, like, okay, whoops, well, we can, see, okay, well, we can, piece apart, what parts are, who's saying what. But there is information lost when you transfer it from one mode to another. And I think we should be placing more emphasis on interpreting the sounds by listening and training our ears so that we can do that. And I have noticed people who have ear training, like musicians, when you play them a recording, they can hear things quicker, more easily. They can hear more things than people who don't have trained ears. So this is something to think about. So this brings us back to respect, restore, replace. And especially respect. So we know that ocean ecosystems depend on sound. And really, we should think about that all of our intrusions into the ocean world in all their various forms, when we are planning those out, we should be considering sound. And while the dynamics of the underwater soundscape may not be intuitive to us, orienting to it is essential for tuning in to what is going on in the ocean. And I think that the intersection of art and science is key to this, and in finding win-win solutions for ocean and coastal sustainability. And I would be very interested, afterwards, anybody who has win-win solutions for coastal sustainability to come and talk with me, because I am creating this network of people working on this.